In today's lesson, we'll be learning the equation for a circle. The equation for a circle is x squared plus y squared equals r squared. This equation only works for circles that are centered about the origin. X and y represent any point on the circle, while r represents the radius, which is the distance from the center of the circle to the edge of the circle. In our first example, we want to determine the equation of a circle with a diameter of 14 units. I'm going to circle the important pieces of information: equation and a diameter of 14 units. The equation for a circle is x squared plus y squared equals r squared. If you don't remember what diameter is, I'm going to draw that on this diagram. So here we have a circle. The distance between two edges on the circle that goes through the middle of the circle is called the diameter. You should know that. While the distance between the center of the circle and any edge along the circle is called the radius. So I'm going to use a short form of d for diameter and a short form of r for radius. Let's make a note for ourselves over here. Diameter is equal to 14. If the diameter is 14, you automatically know what the radius is. The radius is half of the diameter, so half of 14 is 7. I'm going to go ahead and substitute in that value. So I'm going to write sub r equals 7. Everything stays the same, and I'm going to replace my r with this 7. I'm going to put it in brackets. I'm also going to have to square this number. So in my next step, I'm going to go ahead and square 7. 7 squared is 49. Therefore, the equation of my circle is x squared plus y squared equals 49. In our second example, we want to determine the radius of a circle with the equation x squared plus y squared equals 100. So let's circle the important pieces of information. We want to find the radius, and we're given the equation of a circle, which is x squared plus y squared equals 100. Let's start with the general equation of a circle. The general equation of a circle is x squared plus y squared equals r squared. Now, the equation that we're given is x squared plus y squared equals 100. You'll notice that several of these terms are exactly the same. The x squareds are the same. The y squareds are the same. However, r squared and 100 are not the same. However, they are equal to one another. So over on the side, I'm going to make a little note for myself. R squared is equal to 100. Now, to figure out what r is, you have to get rid of this exponent of 2. The opposite of to the power of 2 is a square root. Now, what you do to one side, you have to do to the other side. So I'm going to square root 100 as well. And when I square root the left side, the exponent of 2 disappears, and the square root of 100, pretty simple, that is 10. Therefore, the radius of the circle is 10 units. In our third example, we want to find the equation of a circle centered at the origin that passes through the point 3, -4. The important pieces of information are equation and the point that is given, 3, -4. At the end of this question, we want to figure out the equation of the circle. Remember, the general equation of a circle is x squared plus y squared equals r squared. We need to figure out what r is equal to, and we can do that because we have a point on the circle. In our very first step, we're going to substitute that point into our general equation. But let's start with our general equation. X squared plus y squared equals r squared. I'm going to write sub 3 -4. Okay? We know that 3 is the x coordinate, so I'm going to put that in brackets over here. And we know that negative 4 is the y-coordinate, so I'm going to put that in brackets over here. Everything else stays the same. You can go ahead and square these numbers. 3 squared is 9. Negative 4 squared is 16. Everything else stays the same. 9 plus 16, pretty easy. That's 25. Everything else stays the same. Remember, we want to figure out what r is equal to. However, we do not have r isolated yet. R is still stuck with this exponent of 2. To get rid of this exponent, the opposite is square root. Now, what you do to one side, you have to do to the other side. Okay, so the square root of 25, pretty simple. That is 5, and the exponent of 2 disappears, and all you're left with is 5 is equal to r. Now, if you want, you can rewrite this so it reads from left to right, and you can write r is equal to 5. Now that we have the radius of our circle, we can finally write the equation of our circle. So again, let's start with the general equation of a circle, which is x squared plus y squared equals r squared. We know what the radius is, so let's substitute that in. I'm going to write sub r is equal to 5. I'm going to put that 5 in brackets. So 5 squared. Now you should be able to square 5 without using a calculator. That is equal to 25. Therefore, the equation of my circle is x squared plus y squared equals 25. And let's just zoom out to show you all the work that went into this one question. In our fourth example, we want to determine if the point negative 4, 5 is on, inside, or outside the circle with the equation x squared plus y squared equals 29. Again, the important pieces of information are as follows. Point negative 4 and 5. We want to figure out if it's on, inside, or outside the circle with the equation x squared plus y squared equals 29. Before we begin, let's analyze the equation of the circle that's given. So the equation is x squared plus y squared equals 29. Just like a previous question, we know that the general equation of a line is x squared plus y squared equals r squared. Therefore, these terms are exactly the same, these terms are exactly the same, and these terms are actually equal. So that means r squared is equal to 29. And when I square root both sides to get rid of the exponent of 2, the radius turns out to be the square root of 29. If you want, you can go ahead and simplify that. I will do that right now. That simplifies to 5.4 approximately. With this piece of information, let's go ahead and make a diagram for ourselves. This might be helpful later. So that is the center of the circle. The radius is the square root of 29, or in other words, that is 5.4. If you go back to the original question, we are given this point negative 4, 5. We want to figure out if this point is within the circle, on the circle, or outside the circle. I'm going to assume that this point, negative 4, 5, is on the circle. If it is on the circle, once I plug it in to the general equation of a circle, I should get a radius which is equal to 5.4, or the square root of 29. If the radius is smaller than this number, that means it's inside the circle. If the radius turns out to be larger than this number, that means it is outside the circle. So let's go ahead and do those calculations. Let's go ahead and do the calculations below. So I'm going to start with the general equation of a line. X squared plus y squared equals r squared. I'm going to substitute in the point that was given in the question, so negative 4 and 5. When I substitute in those values, I'm going to use brackets. Everything else stays the same. Negative 4 squared, pretty simple, that's 16. 5 squared, that's 25. Everything else stays the same. Let's simplify these numbers. 16 plus 25 is 41. To get rid of this exponent of 2, you need to do the opposite operation, which is square root. And what you do to one side, you have to do to the other side. So the square root of 41 is equal to the radius. Now, again, if you want to write this from left to right, you can. So I can rewrite this as r equals the square root of 41. If you want, you can throw that into a calculator and you should get approximately 6.4. Let's compare these numbers. We figured out basically the distance between this point and the origin, and we also know the radius of this circle, which is the square root of 29, in other words, 5.4. You'll notice that 6.4 is greater than 5.4. Therefore, this point is located outside the circle. So I'm going to make a concluding statement. Since the square root of 41 is greater than the square root of 29, therefore, the point is outside the circle. In our fifth example, we want to verify that the point negative 3, 6 is on the circle with the equation x squared plus y squared equals 45. The important pieces of information are this point as well as the equation x squared plus y squared equals 45. If this point is on the circle with this equation, the radius should be exactly the same. So let's go ahead and do some work for that. So I'm going to write down the equation of the circle, which is x squared plus y squared equals 45. Again, the general equation for a circle is x squared plus y squared equals r squared. Therefore, all these terms should be equal to one another. So r squared should be equal to 45. And if you square root both sides, the radius is the square root of 45. We're going to do something which is very similar to the previous question. I want to figure out the radius of the circle that contains the point negative 3, 6. So I'm going to say sub point negative 3, 6. So negative 3 goes in brackets and it gets squared. The 6 goes in brackets, gets squared. Everything else stays the same. Negative 3 squared is 9. 6 squared is 36. Everything else stays the same. We can go ahead and simplify some of that work now. 9 plus 36 is 45. That is equal to r squared. Remember, we want to get rid of this exponent of 2. To do that, we do the square root. When you do to one side, you have to do to the other side. So I'm going to square root 45. That's going to leave me the square root of 45 is equal to r. I'm going to rewrite this so this reads from left to right. R is equal to the square root of 45. Let's go ahead and compare these values. As you can see, the radius is 45 and the radius over here is the square root of 45. That's what I meant. So let's make a concluding statement. Therefore, the point is on the circle. In our final example, we have a circular track that is being constructed with a railing along the outside. The equation of the circle representing the outside of the track is x squared plus y squared equals 169. We want to find the amount of railing that is going to be required. So let's highlight some of these key pieces of information. It's a circular track and there's a railing on the very outside. The equation of the circle is x squared plus y squared equals 169, and we want to find the amount of railing that is going to be required. So let's do a diagram to help us visualize this information. Because we want to find the amount of railing on the outside of the track, that means we want to find the perimeter of this circle. If you recall, the perimeter of a circle is also called the circumference. And the circumference equation is 2 times pi times r. It should be pretty straightforward. We know what 2 is, it's a constant. We know what pi is, it's 3.14 as an approximation. But we need to figure out what the radius of this circle is. And we can do that with the equation for a circle. Let's write down the equation of the circle, which is given. That is x squared plus y squared equals 169. If you remember, the general equation of a circle is x squared plus y squared equals r squared. These terms are equal to one another, including 169 and r squared. So let's go ahead and make them equal to one another. So we have r squared equals 169. To get rid of the exponent of 2, you square root both sides, which gives you 13. So the radius is 13. Now that we have the radius, we can go ahead and substitute that into the circumference equation. And let's do that down here. So I'm going to rewrite the general equation, which is 2 pi r. I'm going to make a little note, sub a radius of 13, which means substitute. So everything stays the same, and I'm just going to put that value in brackets. Once you get to this point, you can just throw that into your calculator. I'm going to round the final answer to 1 decimal place, and that will give us 81.6 units. And that is our final answer. I'm going to write a concluding sentence. Therefore, 81.6 units of fencing is required. I'm just going to zoom out to show you all the work that was required for this one question.